Hi guys, today I'm gonna talk about in spontaneous decay of atom, how can we determine photon's spin? To summarize, there is some correlation between photon's polarization and the vacuum field's polarization. Let me tell you briefly about background of photon spin. Actually, photon is massless gauge boson, so that there is no spin zero photon. And there are many kinds of polarization of photon. Left and right circular polarization has spin +1 and -1 each, and elliptical and linear polarization is actually superposition of left and right circular polarization. Okay, today I'm gonna talk about LCP only because right circular polarization follows analogously. We can write left circular polarization like this because when we consider real part, which implies electric field, we can check this equation. And when we fix time component, then it leads to this equation. And the electric field rotates counterclockwise in space. That's why we call left circular polarization. Also, when we fix spatial component rather than time component, then we can check that electric field rotates counterclockwise. That's why spin is +1. Okay, spontaneous decays. I will skip time perturbation theorem and electromagnetic interaction in quantum mechanics and Fermi-Gordon rule here. But what you have to know is this A is vacuum field. This is actually operator in quantum electric dynamics, but in semi-classical limit, it's just plane wave. And there are many options here, but this leads to this equation. And this component can be expanded by spherical harmonics. So because of selection rule, delta must be 1, so EP2 1s transition is dominated. So this transition matrix contains this integral, and in case initial state is M1 and final state is ground state, then M should be -1. So we can check that this component effect decays. It leads to photon emission. Also, because of the angular momentum conservation, photon has spin +1. As I told you before, this is exactly left circular polarization, and it can be represented with this equation. And it is same as this, right? This is vacuum field's polarization. This is emitted photons polarization. Conclusion: vacuum field polarization that leads to the gamma emission determines the photon's polarization. Thank you.